Hi everyone, welcome back to my channel, Tamil Quality Inspection. Today we are going to discuss about the topic on CSWIP 3.1 practical examination. I'm happy to see you again in another video. One of our subscriber he requested to make a video in English. Today I'm here. Let's get started. Once you enter inside the examination hall, TW representative, they will provide a examination accessories, that is tab, torchlight, scale, bridge cam gauge, uh, 8 segment of welding specimen. They call it as a ring. And in TWA there is a two ring, ring one and ring two. Ring two is more tougher than ring one. I hear from so many peoples, and they will provide a rough sheet where you're going to work it out if you have any calculations for the general papers. And defect marking rough sheet, it's for practical examination. You should mark the defect and acceptance criteria in the rough sheet, and uh, after that you have to feed in the tab. uh, if you feed your answer directly to the tab, will be uh, you'll be confused, and it will be quite difficult to answer. So you have to fill the defect marking oxide, then you have to feed your answer. It's my advice. And they'll provide the acceptance criteria sheet where you can see the defect type and their explanation and criteria value. These are the photo of the accessories where we are using during our examination: torchlight, tab, bridge cam, and ruler. It's a look like a paper. It is flexible. You can use it to measure the length. And ring, that one, 8 segment of welding specimen, where you are going to identify the defect. This is the acceptance criteria for your practical examination. There are 13 type of defect you're going to identify during your examination. And in examination, they have mentioned group A and group C. You have to find out the criteria, acceptance criteria for group A and group C only. You have to answer. In remarks, they are explaining about the defect, how the defect will be. It's like a explanation, like you can call it as a definition. The defect type, each defect type is denoted with the letter like A, B, C, D, E, up to M. First defect type is excess well metal. If you notice any well metal is above the parent metal, you have to consider as excess well metal. So they have mentioned the remarks. uh, in group A, the acceptance criteria will be very closer, very stringent compared to group C. In group A, maximum 2 mm of excess well metal height they are accepting. In group C, 5 mm, up to 5 mm they are accepting. If it goes beyond 5 mm, it's rejected in group C. Underfill. In underfill, if you notice any well metal below the surface of the parametal, either in the middle of the well metal or near to the parent metal, that well metal should be below the parent metal. You have to consider as a underfill. In group A, it's not permitted. If you notice any underfill, it's rejected in group A. In group C, maximum 5 mm length they are accepting. If it goes beyond 5 mm, it's rejected. Slag or silicon inclusion. If you are noticing any non-metallic inclusion in the middle of the weld metal, or between parametal and weld metal, there is a slag inclusion. That is considered as a slag inclusion. In group A, is not permitted. In group C, it's permitted. You have to measure the length of the slag inclusion. Either you measure continuously or intermittent. If you noticed slag inclusion in multiple position with a gap, that's intermittent. So that length should not be exceed more than 20 mm. If you noticed slack inclusion with intermittent with a gap, you have to measure the length of each slag inclusion, and you have to add that accumulated total should not go beyond 20 mm in group C. Okay. Undercut, it denotes with a notation D. uh, if you are noticing any metal, any parametal near to the groove is melted, or the toe of the well metal is melted, or any adjacent well melted is melted, then it's considered as a undercut. Undercut can be occurred in well metal also. If there is a two run, you can see the undercut. So be careful. Either near to the groove, which melted the groove with the parametal, or also between the run of the well metal. If you are noticing groove, the parametal melted, that groove melted in the parametal, or that melted area in the well metal, is considered as an undercut. Sharp indications is not allowed. If you have a sharp undercut, it's rejected. So the undercut should be blended smoothly. Okay. Then you have to measure the length of the undercut. Okay. Your undercut is smooth. Then you have to check with second criteria. Length of the undercut should not exceed beyond 5 mm continuously or intermittent. Continuous means in one area you are having a undercut with the length more than 5 mm, that is rejected. If it's less than 5 mm, it's accepted. Then you have to go with the other criteria like depth. Depth should not go beyond 1 mm in the weld phase. In root side, undercut is not permitted. Directly you can reject it. Here also, uh, they have mentioned accumulative totals. You are noticing multiple undercut with the gap. There is a intermittent undercut. You have to measure the total value of the undercut, total length of the undercut, and you have to check with the criteria. It should not go beyond 5 mm. And group C, in group C, you can see you have to measure the length. In You have to see this undercut in both side, root and face. It should not go beyond 25 mm, that length, continuously or intermittent, and depth, maximum depth 3 mm. We are allowing in weld face and root. Okay. Here also you have to consider continuous or intermittent. You have to take the accumulated total and you have to check with the value. Okay. Then stop and start. There should be no part of previous weld cutter showing at the restart. If you are noticing any crater, weld crater, that is a poor stop and start. In group A, that length should not be more than 30 mm. In group A. In group C, it should not go beyond 10 mm. Within 10 mm, they are accepted. Okay. Here you can see the acceptance criteria value is comparing to group C. Group A have much more tolerance, and lack of cyber fusion labs and cold labs. In remarks, they have mentioned incomplete fusion between the well metal and parallel metal. If you are noticing, well metal is not fused properly between well metal and base metal, you have to consider as a lack of sidewall fusion. And if you are noticing that well metal is not fused between the well metal, there is a consider as a, you have to consider as a lack of internal fusion. Okay, if you are noticing internal fusion and lack of sidewall fusion, you have to consider lack of sidewall fusion labs, cold labs as a defect. And in group A, it's not permitted. In group C, you have to measure the length of the this one fusion, either continuous or intermittent. You have to take the accumulated totals, and that value should not go beyond 15 mm, either continuous or in accumulated total. Ox strike, it damages to the parallel metal and well metal from a touchdown of electrode or electrical source. If we struck the electrode on the parallel metal or well metal, it considers arc strike. So in group A is rejected, it's not permitted. In group C, in two place, two arc strike is accepted, it's permitted. This arc strike you can see on the weld face, you cannot see on the root face, so be careful. And mechanical damages, it denotes the letter hatch. uh, if if you see any damages to the parent metal or well metal, like sizzle marks and grainy marks, that you have to consider as a mechanical damages. And the stray tag weld also, you should exclude, you should omit, like stamping, hot stamping, any engraving marks, pop marks, you should omit, you should not consider as a mechanical damage. In group A, no stray tag weld is permitted. If you notice any tag weld, it's rejected. Always tag weld will be in the root, not on the face. Okay. Any mechanical damages if is short is rejected. It should be smoothly blended. And the maximum depth they are allowing 0.5 mm. That also they are allowing in only one location. That mechanical damage should be in only one location. If it's uh, exceeded or in more locations, if you notice in multiple places, then it is considered as a rejection. In group C, one stay tag weld is permitting. They are permitting one tag weld, and sharp mechanical damages are not allowing. It should be smoothly blended, and depth maximum 1.5 mm they are allowing, and it allows in two locations. For the penetration, if the well metal exceed in the root above the base metal, there is a penetration. You can call it as a excess root penetration. In group A, maximum the height they are allowing up to 2 mm. In group C, 4 mm they are allowing as per the criteria. Lack of root penetration. If you are noticing the absence of well metal in the root, and it shows two root face, you are seeing the face of the two face of the parameter, and there is no well metal. There is no filling. There is absence of well metal. Then it's considered as a lack of root penetration. So you have to measure the length. That length should not go beyond 5 mm in group A. In group C, 15 mm, up to 15 mm they are allowing. If it goes beyond 50 mm, it's rejected. Then lack of root fusion. It's same like fusion only. That will be in a root. That well metal to well metal is not fused properly, or well metal to parametal is not fused properly. Here you have to consider the length, either continuous or intermittent. That length should not go beyond 4 mm in group A, and in group C up to 25 mm. They are allowing above 25 mm. It's rejected in group C. If you are seeing intermittent, then you have to measure the total value. The total value you have to verify with the criteria. Then burn through. Mostly, you cannot see that burn through in the welding specimen. So no need to consider burn through. No need to mark. Don't waste your time. So you cannot see burn through in the specimen. Then root concavity. Root concavity means that weld metal is below the surface of two parallel metal. That weld metal should be below the two parallel metal. That is considered as a root concavity. It will be like a concave. Okay. In group A, it's not permitted. In group C, maximum length 20 mm they are allowing. If it goes beyond 20 mm, it's rejected. Total 13 defect you have to identify it, the specimen. A, B, C, E, F, G will be on the face side. H also it will be on the face, or either face or root. I, J, K, L, M, it will be on the root side. And undercut, it can be either in root or face. Okay, A, B, C, E, F, G. You have to check in the face of the weld. Okay, and it is a rough sheet. You can see the same thing in the rough sheet, that defect marking rough sheet. Okay, in first you have to identify the imperfection on the sample. That one you have to mention in the one. Here you have to mention it. A is accessible metal, B unruffled. If you noticed accessible metal, you have to mark it in row 1, and in row 2 you have to check with the criteria category A or group A, whether it's accepted or not. In group C, category C, you have to mark in row 3. A, B, C, D, E, F. It is a notation of the defect type. Once you finish this segment, you have to go to segment B. Okay. How we are going to mark in the defect marking rough sheet. Just first we have to take segment A in the welding specimen, and you have to identify the defects. How many defects are in the face? How many defects are in the root? If you noticed excess weld metal, always we can see excess weld metal in the all the samples. So that you can mark it. So that is in the rough sheet. If you notice any poor stop and start, you have to mark. Any mechanical damages, any defect, you have to mark. So not all the defects will not be present on the well sample. Only some defect it will be on the well sample. So you don't need to worry about that. What are the defect you are identifying, you are noticing, you have to mention in the rough sheet. Then next one, you have to check with the criteria. If you identify the accessible metal, okay, then you have to check whether it's accepted or not. If it accepted, no need to mark. If it's rejected, you have to mark. Okay. For example, the accessible metal is beyond 2 mm, is rejected in category A, that is 2. So it's rejected, so I marked. It's you have to follow for same for all the defects type and criteria. Okay. uh, Before answering to your uh, question, the TWA representative they will provide a username and password for your tab, and he will wrote on the board, and you can see wherever whenever you want. Once you enter your username and password, then another tab it will open where you have to mention your examination code and uh, password key. That one TWA representative providing a sheet for each persons, so you can get it that credentials in the paper, and you have to enter inside that tab that exam code and pass key. Then after that you will get this menu. First you have to select the segment. Okay, you have to select the segment A. In segment A again you have to select defect type. That one everything you have to select in the tab. Okay, after defect type, what are the defect you have identified? If I am identifying accessible metal, so I have to mark here. Then if I am going to mark stop and start, then you have to mark. Once you marked, it will be highlighted. You can see, okay, these are the defects you are identified. You can ensure, you can verify with the your rough sheet whether we marked properly or not as per the rough sheet. Okay, mechanical damage. If you notice mechanical damage, you have to mark. And if you notice lack of road fusion, if you noticed uh, concavity. Okay, once you marked all the defect, then you have to go to group A. Here there is a next button will be there, so you have to click that next option, so it will go to group A. Okay, in group A you have to check whether it's accepted or not. So if it's rejected, you have to mark accessible matter is rejected, so I marked. If you are identifying the defect in identifying defect, but the criteria in criteria wise it's accepted, means you should not mark. Okay, directly you can consider as a accepted. no need to mark it. Okay. Once you finish the group A, then you have to go to group C. Okay. Then in group C, what are the defects are rejected, you have to mark it. If stop and start is rejected, then you have to mark it. Then if it's root concavity is rejected, you have to mark it. Once you finish the segment A, defect type, group A, group C, then you have to click next. Then you'll go to segment B. Okay. Uh, I think this video is very much interesting. Uh, you understood very well. In the next video, we will see some other topic. Until bye bye, take care. See you. Thank you.